Hey guys, so today we're going to be talking about some applications of trigonometry, and we're going to start off by talking about some concepts that you need to know for triangles and how they apply to trig, and let's go. So the first concept you're going to want to know is, hold on, let me get out my pen here, the side angle side property, also known as SAS. So basically, this property just states that if two sides and the included angle of one triangle are equal, respectively, to two sides and the included angle of a second triangle then the triangles are congruent. Little boo-boo there. Okay, so I'm going to draw out quickly what this would look like. Oh me, my pen is not working. 1 second. See, as you can see, these sides are congruent. Angles are congruent. This last side is congruent as well. So both of the triangles are congruent. The next concept we're going to be discussing is called angle side angle, also known as ASA. And this concept basically says that this concept basically says that if two angles and the included side of one triangle are equal, respectively, to two angles and the included side of a second triangle, then the triangles are equal. Formerly known as congruent. And this would look like something like this. So you can see, focusing on those two similar angles there. The side, of course. Both sides are congruent, which also means both inner angles are congruent. So that is angle side angle. side, 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 also known as SSS or S. This concept basically states that if three sides of one triangle are equal, respectively, to three sides of a second triangle, then the triangles are congruent. And this is going to look something like this. Let me draw it right here. No, I'm not the best drawer, but I tried to draw them as similar as possible. They don't really look similar, but you get the idea. These sides are the same. These sides are the same. Of course, you know, they have, this one can be A, B, C, F, you know. So they're congruent. There you go. So now, we're just going to be looking through the actual applications of trig that apply to these triangles. So, let's talk about the law of sines. So, let's draw out a triangle here. So this is what's known as an acute triangle. And an acute triangle basically has angles that are less than 90 and has a right angle in there, as you can see. So we're going to label this A, B, C, D, A, H, C. So, in this triangle, the sine of A is equivalent to H over C, or H equals C sine of A. Now I'm going to show you how the law of sines works in an obtuse triangle. So we're going to label this acute, just for reference. Okay, obtuse, getting ready to draw an obtuse triangle here. Gonna draw it in a different color. I drew this one pretty big. Alright, so we're gonna label that C, A, C, B, and C, A, B. There's a right angle there, D, H. Okay, so this is our obtuse triangle. And in this triangle, the sine of C is equivalent to H over A, or H is equivalent to A times the sine of C. So now I'm going to elaborate on this. So as we can see here, since the sine of H is equal to C times the sine of A, that would also mean that A times the sine of C is equivalent to C times the sine of A, which would mean that when written as fractions, A side A over the sine of angle A is equivalent to side C over the sine of angle C. And the same thing works down here. For the obtuse triangle, sine C equals H over A, but H also equals A times the sine of C, which means that side A over the sine of angle A is equivalent to side B over the sine of angle B, and thus also equal to side C over the sine of angle C. Sorry, it's hard to get the example right here. So I'm drawing out my triangle. A, C, B, A, C, B. This is what I do to remember like which angle's which side is which. I just go A, C, B, A, C, B, A, C, B. Like I go like down triangle, like kind of like down triangle and then up like that. Okay, so we're gonna say that angle C is 63 degrees and angle B is like what, 55 degrees. Then we're gonna say that side A equals 5 meters, just for reference. So right now in our problem, we're looking for 3 things. We're looking for angle A, side B, and side C. So the first thing we can do to solve angle A is just remember that one of the basic knowledges of trig and triangles or anything is that all the angles in a triangle will add up to be 180 degrees. So we can say that 180 minus 63 plus 55 is going to equal angle A. So 63 plus 55 would be 118. So 180 minus 118 would give us 62. So angle A is 62 degrees. Now to find side B, we're going to use the law of sines. So remember what we talked about back here. Remember these? We're going to get to use them. So now that we've figured out angle A, we can use that to find angle B, or side B. So let's write out our work over here. We know that side B over the sine of angle B is equivalent to side A over the sine of angle A. So here in our problem, we can say that B over the sine of angle B, which in this case is 55 degrees, 55 equals A, which we know is 2. Bless me. Angle A, which we know is 5, over the side A, which we know is 5, over the sine of angle A, which we now know is 62. So the sine of 62. So we're going to get out our handy dandy calculator here to solve that. So first thing we're going to do is multiply sine of 55 by 5 and then divide that by sine of 62. So basically, B ultimately equals 5 times the sine of 55 over the sine of 62. Like that. So first we're going to take the sine of 55 sine times 5 equals divided by 62 sine equals 4.6. And we're going to round to the hundredths place, so we're going to say that side B is 4.64 m. And now to solve sine C, we can use the law of sines once again. So side B we now know is 4.64 over the sine of 55 equals the sine of 63 over C. So this tells us that C equals 4.64 times the sine of 63 over the sine of 55. So we're going to put that in our calculator to solve for C. So 63 sine times 4.64 equals, divided by 55 sine, equals 5.04701291. And we're going to round that to the hundredths place once again. So that's going to make C 5.05 meters. So that's all we're going to get into today. Thank you guys so much for watching, and I hope this helped to expand your knowledge on the law of sines and some applications of trig. Bye!